In this video I'm going to introduce the char type and escape sequences or characters. The char type allows us to create variables to store characters such as T or Z, whether it is uppercase or lowercase or 3 and so on, as well as special character types such as the escape sequences that I'll talk about later on in the video. We have an example for the syntax for a char or a character variable declaration and initialization. Char is the type specifier, then we provide a name, so grade symbol, and we can initialize that to some character such as A. A variable of type char will use 1 byte of memory. Notice how the character literals are represented by the character itself. So A, for example, enclosed in single quotes. String literals are enclosed between double quotes. Now that we have this grade symbol, let's say that changes later on in the semester or later on in the year to a B. You won't just do grade symbol, the assignment operator, and B, for example. You will have B between single quotes, and you'll assign that to the grade symbol. Okay, a quick demonstration in Visual Studio. Let's say we want to create a variable that stores some character. How do we do that? Well, we need to use the type specifier char. Then we need to specify the variable name. I'll just call it grade symbol for this example. Use the assignment operator. We assign the character literal A to the grade symbol variable. We end this off with the semicolon, and once again notice the character A is enclosed in single quotes, not double quotes. And I'll just do something like this to print it out, so I'll do cout grade symbol. And it'll print out A, whether that is in uppercase or lowercase. Okay, it'll print that out fine. Now let's say my grade changes later on. So the grade symbol variable now stores this character B, and then we print out after the grade change, and then I'm going to print this line out again. Build and run that. We get A, and after the grade change we get B. Of course you can prefix that with some string literal like this. Just as an example, so we get my grade is A, and then my grade changes for some reason, so my grade is now B. Simple example, but you can see an example of how we can declare and initialize a character, and then also how you can do an assignment. So later on you want to change it, we assign B to that variable, and we can print it out just like an integer or a float. Now there are some special characters that I also want to mention. Let's say for example we want to do another inline here somewhere. I'll just build and run this again. Okay, let's say we want an extra space in between those. Now we have to do something like this. Now you can do stuff like this and build and run that. Okay, now you see we get a space right there. But the point of this is now you have to do a bunch of inlines. So let's say we want to do another one here. Okay, something like that. Also, let's say you want to use the tab such as in Word when you can press tab, and in that way you can space things out. Let's say you have a bunch of subjects such as mathematics and physics and so on, and you want to create some table printout with all of your grades. How can you do that? Well, we have special characters in C++ that allow us to create a new line in a different way than using endline. And we also have a special character for tabs and more, and these are called escape characters or escape sequences, and I'll talk about this next. Next, I want to introduce some special characters that are called escape characters or sequences. So when you search for these in your web browser, maybe you Google these will typically be called escape sequences, but I refer to them as escape characters because you can store them in variables of type char, just like regular characters. Now these special characters start with a backslash character, and that backslash character signifies that another character is going to follow, and the character that follows the backslash, such as N or B, will have a special function that it does, and we'll look at the different ones that we have in a table just in a second. Now it's important to note that this backslash character followed by another character is just one character, even though it may seem like two characters. Okay, it only counts as one character. Here are the escape characters. We have the new line character. Okay, that is backslash n, that is the new line character, and the cursor is going to jump to the next line, so that is similar to the end line that we would typically do at the end of a cout statement. Then you have backslash r, that is the character return, and that is going to reset the position of the cursor to the beginning of the line. The implementation is compiler dependent, but in Microsoft it doesn't delete the characters. So as we'll see in an upcoming example, if you put out more characters in the same statement that is following the character return escape character, the characters that you put out will override the existing ones on that line. The character return escape character is not used that often, but the next one is the tab. So we have \t for that. That is going to do a horizontal tab. And with that, the cursor is going to jump to the next tab column. This is typically equivalent to 8 spaces. You also have a vertical tab escape character, which is denoted by the \/ and v. And then you also have a form feed escape character, which is \f. Those are not in this table because we are not going to use them. Those we use to perform printer operations. Next we have the \b escape character, that is for backspace, where the cursor is going to move back by one character, and typically that is also going to delete the character, okay, but that is compiler dependent. Then we have the \ and the single quote, and the \ and the double quote, and also a \ with another \, and you'll use those when you want to include a single quote or a double quote, or the \ respectively, within a string literal. Of course, if you use the double quotes, that typically denotes the start or the end of a string literal, also referred to as a character string. And with the single quote, that typically denotes the start or the end of a character literal. So if you want to use those within a string literal, then again we are provided with special escape characters for those. We start with the \, and then you do the single quote or the \ and the double quote, and then you can use those within a string literal. Now what's up with this \ character? Why can't we use that in a string literal? Well, that's because the \ character is used as a continuation character. Now what does that mean? Well, when a new line character, or in other words the return key, follows the \ character that is in a code line, then the compiler will ignore the \ and the new line character as well. And as we'll see in a demo here shortly, this will result in the joining of the line containing the \ character and the line that follows in the source file. I have a quick example in Visual Studio in the main function. You will see in this first line here I have a comment, a line comment, and of course, as I mentioned, with the line comment, it's going to comment out everything that is on that line. But notice here that at the end of this silly line that I have here, I do the \, and you will notice on the next line I try and print something out, but the text is green just like in the comment. That should hint to us that that is also going to form part of this comment up here. Following that, I simply print out game over. What do you think is going to happen when I build and run this? Well, let's find out. Ctrl F5 to build and run. It will only print out game over. It will not print out this line right here. The cout statement will get commented out because we have the \ character right here, so we are doing line splicing, and that will mean that this will also basically be commented out, okay, because this is what's going to happen. The compiler is going to ignore the \ and the new line character. What is the new line character? What do I mean by that? Well, that is when you press enter or return. So again, when you do the \ followed by enter or return, like that, the \ and that return is going to get ignored by the compiler. So for example, where we print out game over, I can do something like this. So I do cout game, then I have the \, and then I do over. So build and run that, and we get game over printed out, just as before. So basically what happens is this. Okay, now where is this useful? Well, of course it's useful if you have a very long statement that you want to break up onto multiple lines. Now you won't see it that often, you try and avoid this sort of thing, but that is why we cannot simply have a single \ in a string literal like this. If you want to add a \, so let's say we want to start this game over with a \, then you have to do two \/ like that. Now the / is fine if you do a single / like that. Build and run, and now we get game over, starting with a \ and ending with a /. Now I would like to point out that we get a warning, not an error but a warning. Single line comment contains line continuation character. So basically it's warning you that this statement here will not execute. Now if you have two new lines, so I'll press enter right here again, then you'll see it's no longer commented out. Build and run. Then that line will print out. What you can also do is, instead of using a line comment right here, remove that. You can comment out only that section, only this part of the line. I'll comment that out, and then it doesn't matter that we have the line continuation right here, because this will not be commented out. It will actually execute. Okay, that is similar to doing this. Now the entire line is not commented out, so this cout statement will still work. Build and run that. That statement still executes. And the same thing is going to happen when we use the continuation character at the end there. Build and run, and that statement will still execute, as you can see right here. Okay, so that was just a quick note for you on why you need two backslashes when you want a backslash within a string literal like this. Now, of course, that is only one part of the story because, as we've seen, the backslash key denotes that we're going to use an escape character. So here, this is an escape character. But what happens if we remove the second backslash? Now we have backslash G. What's going to happen in that case when we do not have that character next to the backslash in that table that I mentioned? So let's just build and run this. You will see it prints out fine. It prints out game over, but it does not print out the backslash. And we'll also get a warning. So we get a warning. The G character is an unrecognized character escape sequence. So it doesn't recognize that as an escape sequence. Same thing if we add it in front of M, for example. Build around that. It's going to print out game over. We do not have the backslash within the string that it prints out. And also we get a warning. M is an unrecognized character escape sequence. Okay, backslash denotes that we want to do some escape sequence, and if the character following the backslash is not a valid escape sequence or escape character, then we'll get a warning, but it's basically going to ignore the backslash altogether and it's going to print out the character following that. But that is also compiler dependent. Again, basically two reasons why we need to use two backslashes if you want to print out a backslash within a string literal. Next we have the backslash A, which is used for an alert, and the backslash 0, which is the null character. Now the null character terminates a string literal. If you have some string literal such as hello, you can think of that string literal as a character string or some character container that is going to terminate or end with the null escape sequence. I just want to introduce that here, but don't worry about it too much. We will learn more about this in the module C++ 102 in a special lesson dedicated to characters and strings. Before we look at a couple of examples in Visual Studio, I just wanted to mention here what the escape characters will look like within a string literal. We have a string literal within a console output statement that contains the backslash n and the backslash t escape characters. What are those again? Well, the backslash n is the new line character and backslash t is the tab character. And you can see that those characters fit into the string literal, just like any other character such as G or M or E. And again, those count basically as single characters. You can also have some character variables such as a new line, and then you can initialize that to the backslash n escape character, and then you can also use that within your statements. Same with the other ones such as the tab escape character and so on. In this example, I have three variables: grade maths, which is initialized to A, grade physics, which is initialized to B, and grade English, which is initialized to D, all of type char. Then I'm going to print out subject, grade, and in between that I'm going to add two tabs. Then I print out math, and then I do my grade maths, physics, grade physics, English, grade English, and you can see where I add tabs right here. As you can see, sometimes you might have to add multiple tabs, so I'll just build around this, and then you can see what I mean here. So those align, right? The subject and the grade, these columns align. Whereas if I remove these tabs, so now I only have one tab between subject and grade, and following math here I only have one tab. But if I build around now, you will see those columns do not align. Just like in a word processor, sometimes you need multiple tabs to line things up properly, because here again English and physics are longer words. If you hover over this, you will see a const char, angle brackets and 10. Now that 10 represents how many characters are in this character string, this string literal right here. That is going to include the null character which terminates the string literal. Now of course that doesn't show up in here, but it is in there. We'll learn more about that as I mentioned in module 102. So math, for example, if I remove this t right here, we have 1, 2, 3, 4, 5 characters, but it'll show 6 between the square brackets in the IntelliSense helper that comes up. That is because the string literal also includes a null character, even though we don't see it in here. Okay, so you can also do something like this. Instead of adding it within the string literal, I'm adding it by itself and build around that. Alright, you'll get that sort of result. You'll often see it like this as well. Now this is actually a string literal that contains the tab escape sequence or character, and it also includes the null terminating character. So this is a string, not a character. I'll undo, and this is now a character literal. So this is a character literal, and then that is a string literal. So here I can do 2 tabs now, build around that, and you'll see those line up, but of course gray doesn't line up anymore. Alright. Now with physics and English we could remove these escape characters. Following math we can remove an extra one right here, and then also between subject and grade we can remove one right here as well. So I'll just remove that one and then build a run. You can see this does line up. We have 8 characters here to the left with physics and English, and then following those 8 characters you have the next column basically. So they do line up in this way, but of course with this example I wanted a space, a tab between the physics and English and the B, so I want a tab between that. That is why we had to go in and add an additional tab between subject, grade and following math as well. But if you had a tab right here, B is going to move to the next column, but with the tab within the math and within the subject grade string, those will also move to the next column, which is going to be over here. So again, sometimes we require additional tabs to get the formatting that we want. That is all I wanted to demonstrate with that. And you can actually change the width, so how many characters you can have within a column, but we'll talk about that in module 102, where we'll talk about characters and streams in a bit more detail. Okay, I have a few examples here. In this first line I do cout, hello, and then I have the return escape character, and then I do hello, and then I print out another string humans. Then here I do the backspace escape character because I want to remove the S character from the string, and then I also print out the exclamation, and then I do the alert escape character. I feel like that's an appropriate place to place that. And then I do console output and want the string to be enclosed between a backslash and another backslash. To do this I have to use 2 backslashes each time, and then single quotes here I want this to be enclosed within single quotes. So I do backslash single quote, and this entire thing of course is also enclosed between double quotes to make sure that that is a string. Then in this string literal right here we have double quotes, so I want to enclose this double quote string within double quotes. Again we do the backslash and the double quote, the backslash and the double quote. Again, with all of these examples we will begin and end the string literal with double quotes. These are also referred to as character strings or character arrays because they are containers of characters basically. Okay, so you have character B, character A and so on, and then you also have these special characters, the escape characters within those string literals. Okay, let's just build and run this and see what we get. Remember that in the first statement we did goodbye, then the character return escape character. I'll just click off here, bring this back up again. That is the line. The string literal contains goodbye \r for the character return. The character return is going to move the cursor back to the beginning of the line. Then we print out hello, and then we print out human over here as well. Then we do backspace, which is going to delete the s from the string. And then we print out the exclamation as well, so we get hello human here. And then of course these will work fine. We get backslashes between backslashes, single quotes between single quotes, and double quotes between double quotes. Now sometimes the behavior that you get is compiler dependent with the character return and the backspace, so I'd just like to note that. But with this example, let's say I remove this right here. I'll just go and delete that. So we do goodbye, and then we do the character return and then hello. Build and run that. And now we get this weird string printed out, hello, followed by Y and E. And you might think why that is. Well, basically what's going to happen is the character return is going to move back to the beginning of the line, but goodbye is still going to be on that line, right? This is similar to pressing the insert key where we start to override what is already there. So hello will start to override goodbye. The first character that we get is going to be H, second is going to be E, then we do L, L and O. Okay, those are going to override the first 5 characters here of goodbye, and that is why we get this YE at the end here, because it's only going to override the first 5 characters. If you don't do hello here at all, so I'll just remove that and build around that. You'll see it prints out goodbye. We do not override anything. To a bunch of ones, and you can see what I mean. So we do 6 ones here, and now E will be left over. Okay, so it doesn't return and delete everything that's before it. It's going to simply move the caret to the beginning of the line, and then whatever follows that is going to override whatever was on that line in the first place. I'll just go and undo here. a couple of times, and let's say we want an extra space in here. What we can do is, I will add a new line character in here, pull and run, and now we get the space that we want. So at the end of hello human, that inline is going to move the character to the next line. Then we do the new line escape character, which is going to move that to the next line again. Then it will print out the next 3 strings. Okay, as we have those statements right here. And this is very handy with strings. Now, of course, we could have done another inline right here. Okay, that also works. But that's a bit longer to type out, so the \n is also an option for you. Similarly, I don't have to do this at the end here. I can do, so I do that new line character at the end, and as you can see, this works fine as well. Now there's a bit of a difference between the \n, so the new line escape character, and the inline. Basically, your output is kept in a buffer, and when you do inline, that is going to flush that buffer. Or in other words, it sends the characters to the hardware device, whereas \n does not flush the buffer. So basically what this boils down to is it's more efficient to send a lot of data, or in other words all of your characters, to a device such as the console output, all at once, as opposed to sending the characters or the data bit by bit or piece by piece. Instead of using inline all the time and constantly flushing the buffer, what you want to do is you want to use \n or the new line character instead. But it's very common to have the inline at the end of a cout statement like this. Okay, instead of doing it in this way. So it's more common to see it in this way. Again, for efficiency reasons, you don't want to flush the output stream too often, and inline will flush, whereas \n will not flush. Finally, in this example, I mentioned that we can store the escape characters or sequences within character variables, as we can see right here, because those are considered characters, even though they may seem like they are 2 characters. We have the \t and the \n, for example, but it is treated as if it is 1 character, so we store the \n, the new line character, in a new line variable, and the tab character, escape sequence, we store that in a tab variable, and then we print out game, tab, over, and then a new line right here. Typically have another cout inline right before the return 0, just to add that one vertical space between our printouts in the function and the printouts that we get in the console. Pull and run this. See, we get game over. So it's going to add a tab, it's going to move the over part of the string over to the next column. Then we have the new line, which is similar to pressing enter or return on the keyboard. And then I do a cout inline, and that's going to give us the space right here before we get the console printouts right here. Press any key to continue. So that is going to wrap up this video. I just wanted to introduce you to characters and the escape sequences. I know it was a bit of a long one, but I hope you found it interesting, and I'll see you in the next video.